This video is for linear functions from average rate of change notes. All right, so we've got a set of data here. It says the average price of gasoline changes over time because of a variety of factors. The table above shows data describing the national average price of gasoline per gallon from January 2021 to November 2021 in the United States. Create a linear model for the data using the average rate of change. Okay. Average rate of change is the ratio, sorry, it cut it off, the ratio of the difference in function values compared to the difference in input values between two data points. The average rate of change of an interval from A to B determined by, okay, f of B minus f of A, B minus A. Mathematically, it's easier to see. Say this is f of B, this would be B. Say this is f of A, this would be A. We're taking the smallest and largest values to create an average, okay? So where A comma f of A and B comma f of B are points from the given data set. The average rate of change represents the slope of the line segment. Connecting points, A f of A, so again, A f of A, B f of B, connecting those points. All right, we are going to use the first and the last data points to calculate the average rate of change. So we're going to start with the biggest first, okay? Y minus Y over X minus X. Make sure you use the buddy system. So here it would be 3.395 minus 2.334 over 10 minus 0. If we subtract this out, we get 1.061. 10 minus 0 is 10. And if we simplify this, 0.1061. That is my average rate of change. My y-intercept would be where x is 0. So my y-intercept here would be 0, 2.334. And so the linear model would be f of x equals, this is my slope, 0.1061 plus my y-intercept. And that's just an approximation of that data, okay? So to show you kind of what we're looking at here, if we plot these points, I apologize that I cannot fit that table on the screen with this. So if I plot these points, so 0 is about, to show you what these hash marks represent, this would be 2.35, this would be 2.45. That gives you a little bit more accuracy. So I would have a point here, a point here, 2.8 would be here, 2.85 would be a little above that line, 2.985, so again this would be 2.95, so 2.985 would be almost to the 3, 3.06, so here this one would be 3.05, so a little bit above that, 3.13, 3.13, 7 would be 3.15, 8, 3.175, and then 3.291, again this would be 3.25, so we would be almost up here, and then 3.395 would be almost to the 4. So that's the data. That's a scatter plot. That's what real world data looks like. if I would graph this equation, the easiest way to graph this equation, we know that this equation goes through these 2 points. So I can take a ruler, I can connect the first and the last data point. And that's my approximation of what the data is doing. And again, it's an approximation. You can see that this equation underestimates what the price of gas should have been. But real world data doesn't always do what it should do.